Alright, this email came across my email account just this morning, and so we're going to make this the basis of a Chapter 3 video. It says, "Hey DI, I have a question for you. Today a bunch of us were standing at the bottom of the chairlift at Panorama. Out of nowhere a snowmobile comes hauling down the trail with no one on it. People move out of the way and it takes off the big bank at the end of the chairlift and sails through the air and hits the Picnic Deli. It was pretty crazy. You probably don't have enough info to find out how fast it was going, but we will have to show you the pictures when we get back. Have a good one, Miles." No, I do not have a lot of information, but the nice thing about physics is you can sort of look at the problem and you can sort of do it without numbers. So let's make some assumptions here. Here you've got the Picnic Deli. And probably over here you probably have a snowbank, and it probably goes down like this, and then probably you have a little seating area right here. And the snowmobile comes over and goes splat into the Picnic Deli. And so here's our little Ghost Rider snowmobile coming down like that. Alright, so let's look at this right there. There's something there's a few things that I want to know. We're going to say that it travels a vertical distance, y. Now I actually don't know, I'm assuming that it probably hit the building below the launch point. But by doing this symbolically, the mathematical equation isn't going to care whether or not y is positive or negative. And we're just going to say, okay, we'll just put it in as y, and then we'll make a decision later as to whether it's positive or negative. And it travels a horizontal distance, x. And now we also want to look at its velocity. So this is going to be its velocity v. This is going to be its takeoff angle theta. So this is going to be vi vertical, vi horizontal. And this is going to give us two equations. Vi vertical is going to be equal to v sine theta, and vi horizontal is going to be equal to v cosine theta. Okay, so hustling right along. We're going to have a horizontal problem. And it's going to travel some horizontal distance x for some time t, and its initial velocity from my previous sheet was v cosine theta. The people in the Picnic Deli probably very much care what the final velocity was, but we don't, and we say that its acceleration horizontally is 0 meters per second squared. So now that's going to give us x equals vi t plus 1/2 at squared. X equals v cosine theta t plus 0. And I'm going to rearrange this, so I'm going to get t equals x over v cosine theta. And that is my horizontal situation. Now, the vertical situation starts off exactly the same way. But now the vertical distance is going to be y, and I don't care right now whether or not y is positive or negative. It's going to also go for the same time t. Its initial velocity is going to be v sine theta. Its final velocity, again, we don't care. And we're going to say that its acceleration is g. And we're going to go same. Okay, now y equals v sine theta times t. T is x over v cosine theta plus 1/2 g x over v cosine theta squared. Okay, now I can rearrange this a little bit. Y equals, my v's cancel, sine theta divided by cosine theta is tangent theta, so this is going to be x tangent theta, so this whole thing becomes x tangent theta, and then this gets kind of messy. We have plus 1/2 g x squared. I'm going to rewrite this as g x squared over 2v squared cosine squared theta. Okay. Now we want to solve this for v. The question is, how fast was it going? So let's first off get this term all by itself. So we're going to say y minus x tangent theta is equal to g x squared 2 cosine squared theta v squared. Now let's flip the whole thing. Okay? So we're going to flip it, so we're going to get 1 over y minus x tan theta is equal to 2 cosine squared theta v squared over g x squared. So now I'm going to just go through this real quick. That means, if you think about it, v squared is going to be equal to gx squared over 2 cosine squared theta y minus x tan theta. Okay, so that means that my v is going to be x over cosine theta times the square root of g over 2 y minus x tangent theta. Okay, so that's my expression without any numbers. So let's see if I can throw some numbers in here real fast. Let's say that theta is 30 degrees. That's a reasonable takeoff angle, I think. Let's say that it drops 10 feet or 3 meters. And let's say that it travels 20 meters horizontally. And let's see how that goes. So I'm going to have v equals 20 meters divided by cosine 30 degrees times the square root of 9.81 meters per second squared over 2 times -3 minus 20 tangent 30 degrees. And I'm sort of running low on time, but let's see if I can bang it out real quick. I'm going to have 20 divided by cosine 30 degrees times square root of 9.81 divided by 2 times the quantity -3 minus 20 tangent 30 degrees. Quit. Where did I go wrong? Probably I didn't come up with 1, 2, 3. I gotta close 4. I gotta close a parentheses. Oh, still not there. Okay. Well, I'm out of time, but I did this previously, and it comes up that V is approximately 13 meters per second, or approximately 30 miles per hour.